Okay, welcome to lecture number 1 in the second unit. This lecture is going to be on atoms, molecules, and macromolecules. I'm going to do a brief overview of all three of these things in today's lecture and get a feel for them so that when we come back in class and read, we have a better sense of what we're talking about. So, we're going to start out with our first of many things here, and keep in mind, this entire unit is going to be based on biochemistry. You may never heard of that word before, or that may be a word you're familiar with, but you don't quite know what it means. What we're going to be studying today is what makes up you. Okay? We just finished talking about the characteristics of life, what makes something living, but we still now have to talk about what actually makes up your body and other things around you. So we're going to be talking about that today and trying to connect the material we just learned to what we've got now. So remember, we started at what is living, and now we're going to be going to, well, now that we know what is living, well, what makes up your body and the living things around you. So we'll start out by talking about the smallest of these things, which is the atom. So, atoms, what are they? Well, an atom is what everything is made of. And when I say everything, I mean everything. The computer screen you're staring at right now, the keyboard in front of you, the desk and the chair you're sitting next to and on, the book you read maybe, or the bed you're going to sleep in, or the food you just ate, everything is made of atoms. Atoms are actually the smallest building block of the universe. So everything that has matter to it, or everything that you can, let's say, touch, all of those things are made of atoms. So what does an atom look like? Well, funny enough, an atom looks like this. It doesn't really look like, a piece of a desk or a piece of a chair, but believe it or not, this is what every atom looks like. So let's go over a bit about the structure here. The structure is made up of a nucleus. The nucleus is right in the middle. We'll call this our nucleus. Our nucleus contains protons and neutrons. Around the outside of that nucleus are electrons. The electrons float around the outside in various directions. So maybe this one is going in this direction, and maybe this one is going in this direction. Basically, they're buzzing around the nucleus at speeds you can't even think of. That's how fast they're going. And what they're doing is connecting to other atoms to make up the chair you're sitting on, or the desk you're in front of. So these atoms are very important. If you look at the skin cells on your arm right now, most of those cells are made of an atom called carbon. This just so happens to be a carbon atom. So the atoms that make up your body, most of them are going to be of this little structure right here. Contains 6 protons, 6 neutrons, and 6 electrons. Every single atom has these 3 things in them, and they all have different numbers. That's what makes them different from each other. But the ones that make up you are called atoms. And specifically carbon atoms, sorry, carbon atoms. If we look at this desk right here, we see maybe some, wood here at the top. We see some metal that forms the body of the desk. Maybe a different kind of metal, maybe a stainless metal that makes up the legs. All of these, every single thing, is made of atoms. Atoms are everywhere, okay? So when you're thinking about, well, what is this computer that I'm staring at right now made of? In essence, the smallest thing you could say it's made of is an atom. Now, when we connect atoms together, we make molecules. So when you put atoms together, you make molecules. For example, just like we had talked about in the previous slide over here, we had carbon atoms over here. Now we're going to go to what's called a sodium atom. A sodium atom is right here, and a chlorine atom is right there. They look pretty similar to the carbon atom, but if you notice, one carbon atom is a little smaller than the second one, which is sodium, and then sodium is a little smaller than chlorine. So every atom has its own size and shape, but they are all used to build things. Okay, so right now we've got separate atoms here. These atoms are sodium and chlorine. What do you think happens when we actually put them together? So we've got separate atoms here. When we put them together, what do we get? We get table salt. How weird is that? NaCl, which were the shapes or symbols for these atoms previously, are separate at this point, and then when you put them together, just like this, in which they actually connect, they form a molecule that you can see, like table salt. You put that on all of your food. Okay? So just because the atom may not look like what you expect it to look like, when you put these atoms together, it may resemble something you're really familiar with. And again, that happens everywhere. So the atoms that things are made of are most of the time combined. And when they're combined in the form of molecules, like this one. All right, so we've got, so far, atoms, which are single building blocks here with protons, neutrons, and electrons. Everything is made of atoms. And when you connect these atoms together, what do you get? You get molecules. Now, your body's pretty big, okay? Compared to the size of an atom, your body is enormous, okay? So how many atoms make up you? That number is enormously large. So what we like to think about here is maybe something a little larger in scale. So we've got molecules here. We just talked about molecules. Molecules can be small or large, but since your body is so big, you are made of what are called macromolecules. And macromolecule means big molecules. Okay, your body is made of these. So what are the molecules you're made of? Well, it includes carbohydrates. Okay, that's something like bread, right? Lipids, which is fat, or let's say butter. Protein, which is meat. Doesn't have to be meat, but it can be. And then nucleic acids. So nucleic acids you get from all of these other products, but nucleic acids make up an essential part of you, which is DNA. Okay, and we'll talk about that a little bit later down the road. But all of these things are big molecules. So what are they? Well, they're made of atoms combined together. Okay, so made of atoms. These atoms are combined together to make molecules, right? And then the molecules are combined together to make big molecules. And that's what you are made of. Big macromolecules. How do you make these? You may be asking. You know, how are my cells made of these things? Well, your body actually goes through a process called polymerization. That's the last thing we're going to talk about today. So, what are parts of a macromolecule? How are we going to build one? Well, parts of a macromolecule include two. Exactly two. The monomer and the polymer. Okay, so the monomer is the simple molecule. It is very small. Think of it as a building block. And if you really want to think of it in a different way, think of it as one Lego. If you still play with Legos, or if you ever did, a Lego is just a toy you use to build structures out of. So this is one tiny little Lego brick. Okay? As you put them together to build a spaceship or a castle or something like that, you make polymers. A polymer is just a big organic molecule made of monomers. We're going to demonstrate this in class, but as we go through this together, remember, monomers make polymers. So this happens when we put building blocks together, and think of it as a Lego set, like a bat cave or a castle or I don't know, of airplane. Okay. It also kind of makes sense when you analyze the words. Mono actually means one, right? Let's put this in here. Mono means one, and mer means part. So, if you're thinking, well, what does polymer mean? You might be guessing, well, it obviously means something related to parts, right? So we got our part here. Poly means many. So we've got one part, monomer. We're going to put all those together to make polymers, which are full of many parts. And that's what we've got to discuss here. So how do we put those together? Very simply. It's called polymerization. And polymerization is when you put these monomers together. So through polymerization, basically every monomer has these connection points. Okay, this is what we would call a connection. Okay, connection. Here's one here. And as these monomers come together, so here's one monomer, and here's another monomer, a building block, right? As they come together, these connection points have to break off so the two smiley faces can connect, just like this. Okay, how are they going to connect? Well, they have to lose some of these molecules. So you'll notice, well, it's O and H, and some more O's and some more H's, right? If we take those off, conveniently, as we take these off and stick our smiley faces together, we make something called H2O. Two H's and one O. That is actually water. So as we connect these monomers together and remove these connection points and connect our monomers into a polymer, we make water in the process. Okay, and water leaves. So polymerization makes a little bit of water and turns monomers into polymers. Let's say we want to break them apart. Let's say, you ate a lot of food and you stored that energy so you could use it for later, but now your body needs it. Now your body needs to break that energy down. Now we go through a process called hydrolysis. Okay? You want to break a polymer into monomers. How do you think we do that? Well, we do the exact same thing in reverse. We take our water molecule, which is H2O, we stick that in between the two smiley faces, that breaks them up, and now we've gone from a polymer into two monomers. Okay, one right here, and one right there. And again, we'll try and demonstrate this in class, but polymerization is just removing water and connecting the two pieces together, whereas in hydrolysis, you're putting water back in there and separating the two apart. So, in conclusion, we've got atoms. Atoms are the smallest thing out there. Everything is made of atoms. If you connect atoms together, you make molecules. Those molecules can be small or large. Your body is made of really big molecules called macromolecules, so we refer to them as very big or macromolecules. And how does your body make those? Well, it makes them through polymerization, where you connect them together and remove water, and your body, if it needs to, breaks them down again to get that energy back through a process called hydrolysis. So as you eat food and you grow and you change, you eat all this food and build macromolecules to, help you get through the day, give you some energy, and ultimately make up you. Okay. So that concludes our first lecture of the unit on small things, macromolecules and atoms. We'll be getting to just macromolecules. We'll be doing a little more on that later. But for now, try and take this in. We'll review it in class. And if you have any questions, please bring them to class with you so we can talk about them. Thanks for listening, and I'll see you in class.